So today we're going to tackle how to solve an equation that has a variable in the exponent. And in order to do that, we're going to have to talk about something called logarithms. Now, when an equation is in this form, we say it's an exponential form, or some y equals b to the x form. Now, in order to get this exponent down to the regular part of the equation, we have to change the form we're in. In other words, go to something called logarithmic form. Now, this form of exponential can be transformed into logarithmic by doing what's known as sliding the base over. If we slide the base, which is currently under the exponent, to under the y term here, except instead of the exponent being superscript, we now make this base subscripted. So we slide it under the y and add this thing called logarithm, which we really don't know what it means right now. It's just there. It's equal to x. So by sliding the base, we change from exponential to logarithmic form. And again, we don't know what log means yet. We'll get there in about 5 minutes, but just hang tight. So what we're going to do is we're going to take and transform each of these exponential expressions into a log expression by sliding the base. So here's my base 15, and I'm going to slide it under the y and add logarithm to that side. So I have log base 15 of y is equal to x. The key thing is identifying the base, then knowing which side to give the logarithm to. So here's the base of x. I slide it under the 10, and that's the side I add the logarithm to. So I have log base x of 10 is equal to 8. Likewise here, 3 is my base. Slide it under the k and add the log to that side. So I have log base 3 of k is equal to w. And still, I have no idea what this logarithm thing means, but we'll get there in a second. So now, we're going to do the same thing one more time, except in this particular example, it's the first example we've seen that doesn't have a variable in it, and it's basically a true statement that we know the facts to. We know that 7 squared is equal to 49. So now, when I take and slide my base, I get log base 7 of 49 is equal to 2. Now we can ask ourselves, okay, well, what does this log do? We know that the square root says what multiplied by itself gives you the number under the root, but this must say something. Log base 7 of 49 is equal to 2. We know that they're all related numerically in some kind of true statement. So I know that 7 squared is 49. So if I look at this, this says what power of 7 does 49 equal? That's 2. And in general, logarithm states what power of the base is the number. So here, once again, 7 is my base. And here is the number I'm talking about. So what power of this base 7 gives me this number right here? And that's the second power. So now we're going to go and evaluate some of these things without using a calculator. So here again, what power of 2 is 8? Well, 2 times 2 times 2 is 8, so that ends up equaling the third power. What power of 5 is 625? 5 times 5 times 5 is 125, times 5 more is 625, so that's 4. Not quite guess and check, but I mean, you have to do a little bit of multiplying in your head. These are a little bit more difficult because I don't normally take and think about 2 times what power is 1/16. So the best way I think to do these is, even though they don't have an equation in here, I would write one and say this is equivalent to x. And since I really don't know how to work with logarithms perfectly yet, I'm going to take and change this to exponential form because we've done a lot of work with that up to this point. So we're going backwards now. We're going to take and slide this base under this x, and in this case we're going to remove the logarithm. So we have 1/16 is equal to, and notice I'm removing the logarithm, 2 raised to the x power. Now we've seen a lot of these problems a couple of days ago, and we know that if we're going to solve this, we have to have the same base. So again, I always look to go to the lowest possible base, which is going to be 2. So I know that 16 is 2 to the 4th power. But now the problem I have is I have 1 in a fraction, 1 not. I want to get this out of a fraction, so I know that if I use a negative exponent, it'll do just that. So 2 to the negative 4th is equal to 2 to the x, and x equals negative 4. So what this says, what power of 2 is 1/16? It's a negative 4th power. This one we might have been able to do in our head. This one I'm not so sure. So again, I'm going to set this equal to x. I'm going to slide my base, which is 1/9 in this case. I get 1/9 to the x power is equal to the 4th root of 3. And again, the issue here is not only do I have an exponent, but I have a radical function as well. So I'm going to probably need to change this into a power and possibly change this into a base, because I don't see any similar numbers here. So I have 3 to the 1/4 power is equal to 1 over, and I'm going to go to a base of 3 squared, raised to the x. Now again, I don't have each of these bases in the same place where I need them. I take and bring this guy up by using my negative exponent. So this is 3 to the negative 2 raised to the x is equal to 3 to the 1/4. Multiply powers. 3 to the negative 2x is equal to 3 to the 1/4. I'm going to move up here. So I have 1/4 equals negative 2x, and negative 1/8 is equal to x. Let's keep going just for some more practice. Again, call this guy equal to x, slide my base, 6 to the x is equal to cube root of 36. Change the base on this and also make it into an exponential. So I have 6 squared, all raised to the 1/3, is equal to 6 to the x. Multiply powers. 6 to the 2/3 equals 6 to the x. So 2/3 is equal to x. Another one for fun. Slide the base, 1/3 raised to the x is equal to the cube root of 81. Probably going to get a base of 3 and get this out of radical form. So this will go to 3 to the negative 1 power. 81 is 3 to the 4th. Cube root is 1/3 power. Multiply powers. I now have 3 to the 4/3 equals 3 to the negative x. Therefore, negative x equals 4/3, and negative 4/3 equals x. These are going to end up being a little bit weird because we have, again, variables in our problem. So again, what power of 5 is 125 to the w power? I've got no clue. I'm going to set that equal to x and figure that out. So I slide my base. I have 5 to the x power is equal to 125 to the w. Again, we're going to need a base of 5 so I can set the powers equal. So now I have 125 is 5 cubed all to the w is equal to 5 to the x. Multiply powers, 5 to the 3w is equal to 5 to the x. Set the powers equal, so x equals 3w. So what power of 5 is 125 to the w? That's a 3w power. Kind of an odd answer. This one's really weird. It's in exponential form right now, yet it also has a log in the exponent. So let's tackle it kind of the same way. Set it equal to some unknown x and slide the base. But remember, we're going from exponential form, so I want to go to logarithmic form. I slide this base, add the logarithm, so that's log base 8 of x is equal to the log base 8 of 5w. Well, if I know that the log base 8 of x equals log base 8 of 5w, isn't it pretty straightforward to say that x is equal to 5w? Kind of like what we did with our powers, but now we're doing it with logarithms, and that kind of leads us into a lecture in a couple of days. Well, that's all we've got. Make sure we do our Connect Ed and our lesson summary, and we'll chat more tomorrow.